everyone, today we are going to learn how to find out the probabilities in the Excel sheets. That means if I am using some discrete probability distribution or normal probability distributions. First of all, on the nature of our X, whether it is discrete or continuous, we can define different kinds of probability distribution. That means if I have X as 1, 2, 3, 4 like that, then I can define my px. Px is nothing but x is equal to small x, the probability that x is equal, capital X is equal to small x. Small x is actual value of your probability. Then this one is going to be one single value from 0 to 1, and as we are calling it as probability, the addition, that is total of all these values, must be equal to 1 itself. This is what probabilities we can define. Now let your X is defined as number of heads appeared. Okay, number of head appeared. That means n is equal to, if a coin is tossed 3 times. Okay, if X is nothing but a number of head appeared, n is nothing but 3 times your coin is going to toss, then your sample space, that is all our outcomes, are going to be either all head HHH or HHT or HTH, like that. That means total 8 number of outcomes we will have, and among that your number of heads in each outcome may differ from either 0, 1, 2 or 3. That means X is equal to 0. Here instead of writing 1, I am going to write it as 0, 1, 2 and 3. Okay, that is what number of heads appeared. Okay, number of head appeared is 0. Then your n is equal to 3. So how many heads can be appeared? Either 0, 1, 2 and 3. So every time when I toss the coin, only 2 outcomes are going to define, either head or tail. Now I am repeating this same process 3 times. Okay, so this one is defined, or this probability is defined for binomial distribution. Okay, the distribution is called as binomial. The binomial distribution can be give the probability with NCX, P raised to X, Q raised to N minus X. Among that, N is nothing but number of trials. X is nothing but number of success. Whenever you call it as a success, that number in that n trial. That means if we are tossing a coin 3 times and I am searching for head, then your X is going to be head and number of head is going to be your number of success. Number of success will be either 0, 1 time, 2 time or 3 time. Okay, then P is nothing but the probability of success at 1 time. So you have to define it here. P is nothing but probability of success. Means if I am tossing a coin, that coin is tossed, so 50% there are chances for head and 50% there are chances for tail. 50% chances, whenever we call a chances word, chance deals with the probability itself. 50% chances means 50 divided by 100, 50 out of 100. That 50 out of 100 means 50 divided by 100. So your chance, a mathematical number, is going to be 0.5. Right? That is 50 divided by 100 can be written as 0.5. Now, for binomial distribution, you have to write down all that probabilities. So, to find out probabilities, we are going to use the formula. Again, you can go from this formula ribbon as well as from f function. Okay, then go for statistical and then binomial distribution. Okay, so binomial distribution, once you define, click the OK button. Here number underscore s is given. Number underscore s is nothing but how many number of times or how many number of success you want. Instead of putting actual value, now I am going to define it for this cell. That means take my number of success as 0. Now trials. Trials is nothing but how many times you are repeating your experiment. Here as I define n is nothing but 3 times my coin is tossed. So number of trials is going to be 3. Now probability underscore s is nothing but the probability underscore s, the probability of success on each trial. Now here I have defined that probability as p. P is going to be as 0.5. Again, this probability is also a probability of success that can be differ from 0 to 1. Now cumulative is nothing but this is the logical value. Again, logical value can be filled with the help of either true or false. True होगा तो cumulative probability define होगा, false रहेंगे तो only probability distribution define करेंगे. Now we will see how that cumulative probability is going to be found. Okay, so just put for cumulative probability it will be false. Okay, and put that okay. So this is going to be your 1.25. Now I am just raising this up to down. So this gives you the probability at x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3. Now just go or just check that whether these all probabilities, 4 probabilities are summing to 1 or not. I am going for auto sum from D4 to D7. That highlighted cells are in under our formula. So just go for it. So it will be 1. By calculating how many times 0 we can have if we are having sample space as HHH, HHT, HTH, THH, TTH, THH, HH and T and TTT. Okay, so only one observation is going to define that 0, x is equal to 0, that is TTT. So it will be 1 divided by 8. Okay, so by calculating manually, I am calling it as 1 divided by 8. Just check down. Is it the same probability? Now 2 heads among that 8 outcomes. 2 heads will be 2 divided by how much? Or how many? 3 divided by 8. It will be your second probability. Okay, so this is how we are going to calculate the probability with the help of binomial distribution. Now here in this command I put cumulative probability as 0. Now we will see how this binomial distribution is going to define with the help of cumulative probability. Again, my number of successes are, I am keeping this function for that whole table. So I am keeping this as C4, my cell number. Then trials will be 3. Probability of success is 0.5. Now here in this cumulative probability, I am keeping it as true. Just to check what that values are going to be. As cumulative probability for first one, it will be 0.125. Then at second it is true, that is they are going to add these two probabilities 0.125 plus 0.375. Then that is what it indicating the probability that number of heads are less than equal to 1. This is nothing but the probability of x is less than equal to 1. Okay, so here I am going to define this as cumulative probability. Okay, so this is the binomial distribution for 3 number of trials with probability of success as 0.5. Now I am going to change my parameters. Let my n is going to be n is equal to 10. my probability of success P is going to be 0.7. Then we will check, just consider X. X number is number of success. अगर आप 10 ट्रायल्स कर रहे हो तो आपका नंबर आइदर नो सक्सेस और फुल सक्सेस. That means either X will tends to 0 or 1 or 2 or 3 or 4 up to 10 ही आएगा, उसके बाद नहीं जाएगा. 6, 7, 8, 9 and 10. That means if we are giving 10 arrows to the hit and we are succeed up to 11 arrows, that is not going to possible. That means our number of success is dependent on that number of trials itself. Now I am defining my probabilities. Probability that X, capital X is equal to small x. Small x are these values. Again I am going to define it with the help of binomial distribution. So go for formulas, then insert function, statistical function and binomial distribution. Fine. Then number of S. How many S are there? Either cell value or put down the actual value. Number of trials are 10. Probability of success is 0.7. Cumulative, first one I don't want, so it will be put as a false, and this one. So this is going to be your probability distribution. Now you can see these are nothing but the probabilities. All these values are between 0 to 1 and all them are positive 1. If you go for auto sum of it, that means total of all these probabilities, just check it is 1. That means whatever I have defined, this is nothing but the probability distribution. Okay, this probability distribution is named as binomial distribution. Now binomial distribution values can be calculated with the help of statistical functions. Now as I am using this statistical formulas, just check on, I am going for this statistical one. Now all these list of formulas are being defined, that is AVE, DEV, then average, average A, average if, average ifs, beta inverse, beta distribution. Now this beta distribution is also one probability distribution, but where our X is defined for continuous one. As I define on the basis of our X, that is whether it is continuous or discrete, we can define different kinds of distributions. Then beta in means inverse. This defines, if you are defining the probabilities, then it will give you the values of X. Then binomial distribution range, binomial distribution inverse. Now this binomial inverse or any inverse distribution is helpful to find out the table value of our probability distribution, which is useful for hypothesis testing. Then chi-square distribution, CHISQ distribution, chi-square RT, chi-square inverse, chi-square test. Then correlation function we have seen. Count means just counting all the numerics in the selected region and all. So all these statistical functions we have already defined. Here exponential distribution, F distribution, F inverse, F test, gamma distribution, all that forecasting we have seen in the regression as well as in time series. Then Gauss, hypergeometric distribution, this linest, logest, log normal, linest and logest is used for our regression one. Then log normal distribution, negative binomial distribution, normal distribution. These all are nothing but our distributions. Poisson distributions. Then probe means probability. Probe is X range, probability range, lower limit, upper limit. This is useful for our qualitative analysis. Then quartile, rank, skewness, slope, standardize. These all functions are already inbuilt with the statistical tools. Now with the help of this X distribution, we can define all these probability distributions. As we have seen the binomial one, now for this binomial one, we can go for this histogram, or we can go for this probability chart also. Just go for it, just insert, then all the chart. Now here, this is nothing but your probability distribution chart. You can go for this one is probability chart. Probability chart for our probability distribution. By using this, we can define. Okay. Now, as I increase my n, that is number of trials, the behavior of your probabilities is going to be like a normal curve. Normal curve is what? Here, the values are being started from 0 and ending up to 10, but the structure of this graph is looking like a hill. That is, it will be defined for more trial, the behavior of your binomial distribution is going to be a bell shape. Okay, now we will see if I raise my n to 30. Just consider my n at n is equal to 30. My probability p is equal to, I'll keep it as same, 0.6. Then my x values are going to be, x value should be start from 0, 1, 2. You just select all them and drag. Instead of typing, we can drag these values up to 30. I am just dragging that value. Okay, so this is what your 30. Then put down the formula. Formula you have to insert for only one time, that is probability that x is equal to small x. Now here we are going to define the binomial distribution. Go for formulas. As I have recently used, you can find the formula for recent also. Okay, binomial distribution, number of s, instead of putting 0, I am going to give the cell address n22. Number of trials are 30. Probability of success is 0.6. Cumulative I don't want, so I am putting it as false. Okay, so this is what your value are. Now here just go to this, at ये cell होता है, उसका ये bracket होता है ना, just go to that. You will have that plus sign, just double click on that. It will be the same formula will be applied to all the cells following to that rule. Okay, so all these probabilities can be defined like this. Now I am going to define the probability curve for this x as well as probability. Now just check, select both the rows, both the columns, then go for probabilities and this one. Now here you can observe the behavior of your probabilities are going to be, the more structure is going to be like a hill. So this is nothing but the normal distribution. Okay, that is, we can define higher number of binomial distribution converted behavior to normal one. Okay, the same part we can define, or same probabilities for normal distributions also we can define. Now normal distribution is what? It is a continuous distribution where x is ranging from -infinity to +infinity, and the probability density function for normal distribution is given with the some complex formula, that is 1 upon square root 2 pi sigma e raised to minus x minus mu by sigma bracket square and all. Now what that mu and sigma are? Mu is nothing, mu and sigma are the parameters of our distribution. Now here in the binomial also I have defined only the two values, where n and p. right? In second example also I have defined only two values, that is n as well as p. So this n, number of trials, and p, probability of success, these two are the parameter value for binomial distribution. You can say parameters means what? These are actual values, by with the help of them we are going to define our distribution. The same part we are defining for normal distribution, as normal distribution is continuous probability distribution which is used to define the behavior of all those variables which are having certain mean and standard deviation, where standard deviation is defined by sigma and mean is defined by mu. Here mu and sigma are parameters of our normal distribution. Just go for it. As I defined, my x is ranging from minus infinity to infinity. So there are so many values we can define for plus as well as minus. Okay. So here the probability distribution or probabilities for normal distribution can be defined with the help of this. X is nothing but our x value for which you are going to define your normal value. Mean is first parameter, average of our normal distribution. Then standard deviation and cumulative. Again, cumulative is the logical number. Logical number can be defined with the help of either true or false. The same function we are going to help calculate for the normal one. Okay. So this is all about our probability distribution. With the help of Excel we can calculate. Thank you so much.